Hey 6th grade, we are going to get started on our final lesson of Module 9. It's Lesson 5, Write and Graph Inequalities. Here's our I can statement, our learning goal for today's lesson. I can write and graph the solution of an inequality to represent a condition in a real world or mathematical problem. And over here on the right side of the page, we have one of our vocabulary words, which is inequality. You should already have this in your notes. But just in case, an inequality is a mathematical sentence that shows the relationship between quantities that are not equal. So some of these little symbols you guys have already seen before when we've done less than or greater than, less than or equal to, and greater than or equal to. This chart here is very important, especially the keywords that can possibly be used. They'll give you clues as to which symbol you need to use. So let's go on ahead and try number 1. It says, a record-breaking low temperature of negative 23 degrees Fahrenheit was recorded in Seminole, Texas on February 8, 1933. So the first thing we have to do is figure out where negative 23 would be and put a dot on it. And on this graph, they're counting by twos, negative 2, negative 4, negative 6. And so when we get down here to negative 22 and negative 24, there's not a specific location, specific spot marked for us, so we just have to put negative 23 right in the middle of those two. It says the temperatures 4 degrees Fahrenheit, negative 3 degrees Fahrenheit, negative 14 degrees Fahrenheit, 1 degree Fahrenheit, and negative 19 degrees Fahrenheit have also been recorded in Texas. How did these temperatures compare to negative 23 degrees Fahrenheit? Well, these temperatures are all greater than negative 23. Because here's 4, here's negative 3, negative 14, 1, and negative 19. We can tell that these are all greater values than negative 23. So, how did these temperatures compare to negative 23 degrees? They are all greater than negative 23. Give examples of other numbers that are greater than negative 23. How many of these numbers exist? So I'm just going to choose some random numbers that are greater than negative 23. So it would be anything on the number line that is to the right of negative 23. So I'm going to say negative 10, 6, 25. That's probably good. And then how many of these numbers exist for any numbers that are greater than negative 23? Kiddos, there are infinite possibilities. Infinite possibilities. Just like, that's an S, by the way. All right. So let X represent the temperatures greater than negative 23. Complete the inequality to describe those temperatures. Well, I'm going to come back up here and take a look at my chart. And we have less than, we have greater than, less than or equal to, or greater than or equal to. Okay, so they're not, basically this one is it's greater than because it's just asking for temperatures that are greater than negative 23 degrees Fahrenheit. This one does not qualify for having an equal to part of the symbol included with it. Let's turn over to page 302. The solution of the inequality x is greater than 2 is all numbers greater than 2, not including 2. An inequality such as x is greater than 2 represents a constraint. And then it tells us that a constraint is a condition that restricts the values of a quantity or variable to a given value or range of values. For the inequality x is greater than 2, the values of x must be greater than 2. So, 2 and numbers less than 2 are not solutions to x is greater than 2. For the inequality x is less than or equal to 4, the values of x must be less than or equal to 4. So 4 could be a solution to x is less than or equal to 4, but numbers that are greater than 4 are not solutions. And here's another one of our vocabulary words in the right-hand corner. The solution of an inequality is a value or values that makes an inequality true. An inequality can have many solutions. So there can be more than one correct answer for these. Here's an example of a constraint, and I'm sure many of you can relate to this one. The constraint of this ride is that you must be 54 inches or taller. Think about all those times you were so bummed when you want to go on a ride at Worlds of Fun or Disney World or wherever it is that you've gone, and you're not quite tall enough to ride the rides. So that's a really relatable example right there. We have that problem all the time. So for number 2, it says to graph the inequalities. We have y is less than or equal to -3. So step 1 says to draw a solid circle at -3 to show that -3 is a possible solution. So when they say a solid circle, it means that I'm going to color in my circle because that shows that -3 is included as one of the possible solutions. Then step 2, it says shade the number line to the left of -3 to show that numbers less than -3 are also solutions. So I'm going to color over the line and I'm going to put an arrow on the end, because that shows that the number line goes on infinitely, which means there's an infinite number of answer possibilities. Step 3 says to check your solution, choose a number that is on the shaded section of the number line, such as -4. Since the inequality -4 is less than or equal to -3 is true, the solution graphed on the number line appears to be correct. You can never check all the possible values for the variable, but checking 1 or 2 can help you feel confident that you have shaded the correct side of your number line. So 1 is less than m. Kiddos, keep in mind there is no or equal to part under here. So for step 1, we are going to draw an open circle. That shows that 1 is not a possible answer. Step 2 says to shade the number line to the right of 1 because that'll show possible solutions that are included. Remember to put that arrow on the end. Step 3, check your solution. Pick any number for m that falls on the shaded section of the number line. So I could fill it in with 7. 1 is less than 7. If the inequality you have just written is true, then you have shaded the correct side of the number line. So does 7 wind up being down here somewhere to the right of 1? And yes, it does. So we know that we have shaded the correct side of the number line. All right, let's go ahead and keep going. You can write inequalities to represent certain real-world situations. Use inequalities to solve these problems. The temperature is at most -2 degrees Fahrenheit. What could be the temperature T? Are numbers less than -2 part of the solution? Well, I'm going to take a look back at the chart on page 301, and here it says the temperature is at most -2 degrees. And in the less than or equal to, at most is one of the phrases. So we know that we're going to be throwing in for our inequality symbol we're going to be using is less than or equal to. So, are numbers less than -2 part of the solution? And yes, numbers less than -2 are part of the solution. Are numbers greater than -2 part of the solution? Nope. It tells us that the temperature is at the most -2, so we can't go any warmer than that. Is -2 included as a solution? And since page 301 shows us on our chart that at most means it's going to be less than or equal to, yes, -2 is considered one of the solutions. So when we write our inequality, we have t is less than or equal to -2. Example B. Raphael needs to buy more than 4 concert tickets. How many tickets could he buy? How many tickets T could he buy? Excuse me. Are numbers less than 4 part of the solution? I'm going to say no, because it says he needs to buy more than 4 concert tickets. Are numbers greater than 4 part of the solution? Most definitely. Is 4 included as a solution? I'm going to check my chart, and it says he needs more than 4 concert tickets, and when I check my word phrases, here's more than, which means 4 cannot be part of the solution. It's just a plain old greater than. So no, 4 is not included as a solution. So when we write the inequality, it's just going to be t is greater than 4. Graph the inequality and use an open circle because the value 4 is not part of the solution. So I'm going to just make a circle around 4. Then I'm going to draw my arrow to the right, going in the direction that the numbers get larger to show that, and it shows that 4 is not a part of the solution. If I had colored in the circle, 4 would be part of the solution. But in this particular question, it is not. So I draw an open circle around 4, and then I draw my arrow, shade in the number line to the right with the arrow on the end to show that all of these numbers to infinity could possibly be part of the solution. All right, make sure you bring these notes and your learning goal and vocabulary words and all of that back to class so you're prepared tomorrow. See you in class, kiddos.